Okay, this is a video, a fraction of, but this time, instead of using counters, it is a fraction video using rectangles to represent fractions of a whole number. So again, it's a fraction times a whole number, and it's a visual representation of a fraction and a whole number being multiplied, because of means to multiply. So I'm going to try and do smaller numbers so I'm not having to draw a lot of pictures. I know. So unit fractions, remember, are when the numerator is a 1, so that's considered a unit fraction, and it has a name. Its name is named by its denominator, so that is a 3, so it's not called 3, it's called thirds. So the name of this fraction is 1/3, and I'm going to be multiplying 1/3 times 4. Well, again, multiplication is repeated addition. So technically this means 1/3 added 4 times. So in symbols, it looks like this. So then, as a visual, as a model, I would need to represent each one of these thirds. Okay, that's not representing thirds yet because I need to make them their namesake. I need to make them 1/3, which means every piece needs to be cut into thirds, and you have to pretend that these rectangles are the same size and cut in the same place. And they're not finished yet, because if it's 1/3, then that means that one part should be shaded or a different color or standing out somehow. Okay, so this is a visual representation.
Kindergarten parents still in the building, please come up to the front lobby at this time.
Apologize for the interruption. Sorry about that. This is a visual representation of what 1/3 looks like. It is that mental picture that I'm asking you to start getting in your head. If I ask you, what does a fourth look like, you could draw me what a fourth looks like, or a third, or a half. Those easy unit fractions. You should have a visual picture, a mental picture in your head of what they look like. So here is a third, plus a third, plus a third, plus a third. So this represents 1/3 times 4. And as you go along, they will remove those addition symbols so that you just see 4 sets of 1/3. Okay, and we aren't adding this all up. They're each thirds because you look at what each box is cut into. They're all the same amount shaded. It better be consistent across the board. And again, consistent with how many they're cut into either, or you don't have a set problem. So this is what we would look for to make a fraction of a whole number into a visual model. Here is expanded notation in symbol form, and here is a visual model of this multiplication problem. So real quick, we'll do, let's say we do an eighth of 3, which means an eighth times 3. So in symbols, this is what the problem looks like: 1/8 times 3, or 1/8 of 3. So first off, the key here is the whole number. It tells me how many rectangles I should draw. So here I drew 4 rectangles because I have repeated this 4 times. So that's why there were 4 separate rectangles. So in this case, I need to only draw 3 separate rectangles. Again, pretend they're perfect rectangles and they're all the same size. This lets me know how much each should be cut into. So each one of these should be cut into eighths, because that's its name, is eighths. So this should be 8 pieces, 8 more pieces, 8 more pieces. I'm not adding them all together. They're just each cut into eighths. So how many eighths would I have? Had to get smart. I had to work smarter, not harder. I started first just doing pieces. Then I was like, wait a minute. If I cut my rectangle in half, and then cut each half in half, and then cut each one of those fourths in half, then I create eighths. Now pretend that they are all the same size and pretty and all that good junk. So now, how much is shaded? 1/8. So in each picture, there is a visual representation of 1/8 times 3. Now, what I didn't do is we didn't answer this previous problem, so I should probably, sorry about that. The answer to this would be, these are thirds, and that's my name, so guess what? My name stays the same. I'm Mrs. Turner. Just because I was repeated several times, I'm still Mrs. Turner. So thirds are still thirds in the end. But how many thirds do I have? I have 1/3, another third, which makes 2/3, another third, which makes 3/3. Oh, there's another third, which makes a total of 4 thirds. Well, that makes sense. 1, 2, 3, I've got 4 thirds. And some kids might say, well, if you took all 3 of these, it would actually fill up 1 whole third, and there'd be 1 left over. That's right. That's because 4 thirds is also represented by 1, and 1/3 is a mixed number. So those are equivalent to each other. So then, back to this, let's answer this problem. So here's the visual representation of an eighth plus an eighth plus an eighth, right? So how many eighths do you see? I see 1/8, 2/8, 3/8. I have a total of 3/8. Again, why am I not adding up all these pieces? Because they're all eighths. And I need to name it eighths. This is an eighth, so my name should stay an eighth. I can only combine things that have the same name. So, and then they keep the name. The name doesn't change. So this will be 1, 2, 3/8. So the answer to this problem is 3/8. And again, we have talked about scale factor. Just a quick reminder about scale factor. This number is being multiplied by a number greater than 1. So if I asked you about this number, well, this one's being multiplied by a number greater than 1, so 3 would be the scale factor. Therefore, my answer would be larger than what I began with. That is true for 1/8. However, if I had said, well, 3 is being multiplied by 1/8, 3 is not the scale factor. If I said 3 is being multiplied by 1/8, 1/8 would be the scale factor, and the answer would be less than what I started with, which is true. 3/8 is less than 3 if I went backwards, because the scale factor is less than 1. So when you multiply by a scale factor that is less than 1 whole, you get something less than what you started with. But when I use 1/8 as the starting point, and that was my scale factor, well, is that less than or greater than 1? That's greater than 1. So I got something greater than what I started with. See, 3/8 is greater than 1/8. All right. So that is how you multiply a fraction times a whole number in using a visual model. I am quickly going to change this real quick because I've only done unit fractions. It doesn't change much. Let's say that I have 3/8 times 3. So I should shade 3/8 in each picture then, is what that means. So now I have 3/8 times 3. So there's my 3/8 shaded in on each picture. So that's 3/8, 6/8, 9/8. So I have a total of 9/8, and some kids would be like, well, 3, 6 would cover that, 7, 8, and I'd have 1 left over. You're right, I'd have 1 whole and 1 left out of my eighths, because 9/8 is the same thing as 1 and 1/8, so it's a mixed number. And again, if we use our scale factor, if 3 is the scale factor, I did end up with something larger than what I began with, than my 3/8. Or if I had flipped it and said that 3/8 was a scale factor, and it's being multiplied by the 3, and it affects the 3 in such a way that the answer is less than what I began with if this was the starting point, and that was the scale factor. Okay, but really what I need you to pull away from is how to multiply a fraction times a whole number. Thank you.